Hey guys, here is some homework help for assignment 7-2. Okay, the very first section of the homework is asking you to write a system of linear inequalities that represents each problem situation. Okay, writing a system of inequalities is very much like writing a system of equations, except instead of putting an equal sign, you're going to put an inequality sign. That's a little. There we go. And you're going to know the sign based on the context of the question. So you really have to read so that you know. Okay, so if we're doing, you can read through number 1 and see how that was done. But I'll give you number 2 as extra help. So Carlos works at a movie theater selling tickets. The theater has 300 seats and charges $7.50 for adults and $5.50 for children. The theater expects to make at least $2,000 for each showing. So, we've got A, which is going to represent the number of adult tickets, and C, which is going to represent the number of child tickets. That's a T. Okay. Now, the example from the book here, they're giving you is X and Y, but I think it's more beneficial to use a letter that represents what you're talking about. That way, in the future when you're finding the value of A and C, you know what you just found out. Okay? So Carlos works in the theater. It has a total of 300 seats. So 300 sounds like if we were writing an equation, it would be an equal sign. But instead of an equal sign, we're using an inequality. All right? If it has 300 seats, then I can put exactly 300 people in there, but I can't go over 300. So the amount of seats that they sell has to be less than or equal to 300. So the number of adult tickets plus the number of child tickets has to be less than or equal to 300. Okay? Now, the charges are $7.50 for adult tickets and $5.50 for child tickets. And they want to make at least, which is a key word for greater than or equal to, 2,000. Okay, so we defined our variables and we wrote the inequalities. And that's all they're asking you to do in this first section. In the next section, what they're trying to get you to do is you get a system of equations, and then you're given a point. So you're going to sub in the x value and the y value to both inequalities, as you can see. And what you want to do is simplify it down to, let's see, 6 is greater than 4. Well, that's true. Okay? -8 is less than or equal to 7. That's true. If they're both true, then yes, this point is a solution to the system. All right? So they have to both be true. If you get a false on the first time through, then you don't even have to sub into the second inequality, because one false is all it takes. All right? But if you sub in the first one and it works, you still have to test out the second one. So I actually want to do number 9. You got to forgive me because I still have a cold here. All right. So one of my equations, inequalities, is 4x plus y less than 21. So 4 times 3 plus 7 is less than 21, and I want to see if that's true or not. On this side, 4 times 3 is 12. 12 plus 7 is 19. 19 is in fact less than 21. That's true. So it's a solution. This is a solution to the first inequality. Let's see if it's a solution to the second inequality. 1/2 times 3 is less than or equal to 36 minus 5 times 7. Okay, so 1/2 of 3 would be 1.5, less than or equal to. 36 take away 35 would be 1. So 1.5 is less than or equal to 1. Nope, that's false. And we have to have two truths. So we would say no, 3/7 is not a solution to the system of inequalities. Now, be careful, because I'm going to talk about this generically here, okay? And so I'm going to have no problem on the board right now. If I get something like 10 is less than or equal to 10, or 10 is less than 10, where the numbers match, sometimes that's allowed and sometimes that's not, okay? It's allowed when there's an equal bar. Then we could say true. But if there's no equal bar underneath the inequality, then we have to say false. So be careful, pay attention to details on those kinds of situations. The last section of your homework is asking you to take systems and of inequalities, graph it, and look for the overlap zone. Okay? So I noticed that, actually this annoys me, all the problems in this section are y equals mx plus b form. There's no standard form ones. There should be. There isn't. At any rate, go to your y equals in your calculator and put in 2x plus 3. Go to your table. Okay. And we'll pull that out. Oh, I can't, because this is not a flip chart. Okay, there we go. Just move that over there. Then I will graph -5, -7, -4, -5, -3, -3, -2, -1. And you know what, guys? Do you see a pattern here? Okay, up 2 over 1, up 2 over 1. Those of you that, know how to graph by hand anyway, you could say, oh, I start at 3 and go up 2 over 1. Okay, now, before I start connecting these, this is one of the most common mistakes that even I make. It's such a habit to just draw in a line after you draw your dots. But remember, in inequalities, we have to ask ourselves, is this a dashed line or a solid line? And that goes back to the equation. So I just graphed this one right here. Okay, I graphed the dots for it. There's no equal bar. So I'm going to connect those with a dashed line. Okay, coloring. How do you tell which way to color? The more I get into this year, the more I like the 0, 0 method. Okay, so if I'm doing this first equation, I'm going to sub in 0 for y, greater than 2 times 0 plus 3. So is 0 greater than, let's see, 0 plus 3 is 3. Is 0 greater than 3? No, that's false. It is not. So I will take my highlighter tool, and or you have your highlighters or your crayons or your colored pencils or your pencil, whatever you're coloring with. And here's the origin. I'm not going to shade on the side of the line with the origin. I'm going to shade on the other side. So when it's false, you shade away from the origin. Okay. Now, whoops. I'll do the other one. Okay. Well, I didn't want that to happen. Okay, now I'm going to graph the other inequality. So go back to my y equals. 2x minus 5. Whoops, not the time symbol. 2x minus 5. What do I notice about both of these inequalities? They both have a slope of 2. Something special is going to happen here. Okay. -2, -9, -1. Again, this is a dashed line because there's no equal bar. Which way do we color? Okay, 0, 0 method. 0 less than 2 times 0 minus 5 is 0 less than, let's see, -5. Well, that is false. So again, I am going to color. Here's the origin. I'm going to color on the other side, away from the origin. So here's a special circumstance, guys, where my shading does not overlap. And I'll reiterate what I said in class yesterday, which is parallel in linear systems of equations means no solution. But parallel in inequalities, sometimes, like right now, it means no solutions. And I would write there are no solutions. However, in some of your it would have been possible if the inequality signs up here were flipped the other way. Then I would have colored yellow the other way, and I would have colored blue the other way, and I would have this green section right down the middle. And I could have had solutions if I had colored in the opposite directions. So be aware that parallel can mean no solutions if you're coloring apart, but it can mean solutions if you're coloring toward each other. Okay, a couple things also I want to put on the video that we did in the book yesterday. Most of your homework ones are going to look more like this when you're done coloring, okay? You're going to have the darkest zone of shading right in, on this area right here, and this represents your solution zone. And your homework is asking you on this section, this last section, to identify 2 points in which the solution that would be counted as solutions. Okay, so if I picked this point right here, like pretty much the middle of our solution zone, I would identify that as 5, 1 for the coordinates. Okay, and if you want to go easy, pick another one, very definitely inside the solution zone. 7, 4. So your homework is asking you in that last section to identify 2 points that would be in the solution zone. But I also want to talk about points that seem like they're in the solution zone, but they're not. All right? Clearly, anything out here in the white zone is not a solution. Okay? If it is in just one of the shaded zones, like this is in just one zone, it's only in the shaded zone for the dashed line. Well, that doesn't count as a solution because it has to be in both. So anything in the singly, that only has one shaded area, it's not shaded in both directions, those don't count. Okay? As you get into like this area, if something falls right on the border, so let's say this one and this one, these points seem very similar. Very similar. This one right here is not a solution because it is on the dashed line. And if a point falls on the dashed line, it is not a solution no matter what. This one is on the border, but it's on a solid line. So this one is good. That one is a solution. We could count that, okay? Now, we're also used to, hey, wherever the two lines intersect, that's the solution. No, not necessarily, okay? At this dot right here, it has the same problem that this dot down here did. It lies on the dashed line. So this does not count as a solution because it is on the dashed line. Okay. The last thing I want to make sure we talk about, and this is killing me, is hazy vixen. Okay? If I see something that says y is greater than or equal to 4, how do you graph that? Well, that's where hazy vixen is like a silly memory trick to help you remember that y equals a number means that you have a horizontal line with 0 slope. So I would go to 4, there's an equal bar, okay, I can still use my 0, 0. Well, I could use common sense too, but I can still use 0, 0 to determine which side to color on. Okay, here's the origin. That's still 0. Okay, when I'm subbing in 0, this doesn't have an x to sub into. Is 0 greater than 4? No, that's false. So I'm coloring above that line. Now, I would also like to think that y greater than 4, numbers like 5, 6, 7, 8, 9, that was kind of common sense, okay, that you would color above the line. Vixen. Vixen is meant to help you remember that when x is less than -1, there's no y in this at all, it's only x and a number. I want you to use the V in Vixen to remember it will make a vertical with no slope or undefined slope. So I'm going to go to the -1 on the x-axis, and I'm drawing a dashed line because there's no equal bar. And then in terms of shading, I can still use the 0, 0 test, except I don't have a 0 for y. Is 0 less than -1? No, that's false. So I am not going to shade, I'm going to shade away from the origin. Okay, so to reiterate, anything in this zone with both colors is a solution. On the border line where it's solid, those would all be solutions. But on this border that's dashed, not solutions. The intersection point, not a solution because of the dashed line. Anything that's in a one color zone, not a solution. Anything in the white zone, not a solution. Thank you. See you next time.